Today's lesson, we will be comparing and ordering rational numbers. When you're looking at fractions, how do you know which one is larger? In this case, it's 13/15. How in the world did I know that? Before continuing with the lesson, I want to review two quick concepts. The first one, inequalities. I will be using less than signs and greater than signs during this lesson, so just a quick review on which is which. So we have the first one is less than, the second one is greater than, and obviously we have the equal sign. And the next thing, we need to review least common multiple. We're going to find the least common multiple between 9 and 12, which means we first just need to list all of the multiples of both 9 and 12. Here are multiples of 9 and 12. Now let's look at which ones they have in common. Looks here, they have 36 in common, and they also have 72 in common. But the key word is least. So what is the smallest multiple they have in common? It is 36. You use this concept when you're finding common denominators in fractions. Here we have three sets of fractions that we are going to find common denominators for to help us decide which fraction is bigger. Now you might be looking at some of them and think, well, some of them are mental math, I just know which one is bigger, and that is fabulous. However, I still want you to practice getting a common denominator. For the first set, we have the denominators 9 and 12, and we actually just use those same numbers when doing the least common multiple. And that least common multiple that we got was 36. So we have to think about how can we change this 9 into a 36, and how can we change the 12 into a 36. To change 9 into a 36, you have to multiply by 4. And whatever you do to the denominator, you also have to do to the numerator. So we would be multiplying both top and bottom of that fraction by 4. And then think 12, how do I change 12 into 36? I would multiply by 3. And whatever you do to the denominator, do to the numerator. So now let's rewrite our new fractions. Rewritten with common denominators, I have 16 over 36 versus 15 over 36. So obviously, the 16 is larger than the 15, which means 4/9 is larger than 5/12. So I will write it with an inequality sign that 4/9 is greater than 5/12. The second one should be fairly obvious which one is larger and which one is smaller because they both have the numerator of 1. However, let's still practice getting a common denominator. So let's think of multiples of 6. It goes 6 and then 12, 18, and then I'm going to stop because I know that 9 also goes into 18. So this time 18 is my least common multiple. And what do I need to multiply my denominators by to get 18? Multiply 6 times 3 and multiply 9 times 2. And whatever you do to the denominator, you have to do to the numerator. So now we're comparing 3/18 to 2/18, and obviously 3/18 is larger, therefore 1/6 is greater than 1/9. So once again we have the greater than sign. Why don't you try this last one on your own, get a common denominator, and then decide which one is larger. For the last one, you should have gotten the common denominator of 20 by multiplying by 5 on one side, 4 on the other. And then you end up getting 16/20 versus 15/20, which means 3/4 is less than 4/5. Okay, let's move on. Here are 3 more sets of fractions that we're going to determine which one is larger, which one is smaller. And this time we'll be comparing their decimals. So for this type of example, I would allow you to use a calculator to find the decimals. However, it's very important that you can do the previous examples, finding the common denominator without a calculator. So for the first one, first, just do 9 divided by 13, 19 divided by 28, and let's find those decimals. Okay, here are the decimals, 0.6923, 0.6785. And what you want to do is go in order and comparing first the tenths, then the hundredths, then the thousandths. So because they both have a 6 for the tenth, they're tied. But now look at the hundredths. We have a 9 versus a 7, and 9 is bigger than 7, so 9/13 is larger. So we need a greater than sign. Okay, quickly divide on your calculators and you can get the decimals for the next set of fractions. Again, let's compare each decimal place. So they both start with the 1, so they're tied, and then they both have a 3, but then we have a 7 versus a 6. But this is kind of a tricky question because both of my fractions are negative. So here we have 7 is larger than the 6. But what do we know about negative numbers? The bigger the negative, the smaller the number. So because 7 right here is the bigger, makes this the bigger negative, it's actually the smaller number. So negative 11/8 is less than negative 41/30. Alright, the last example for this set of problems. It's a little tricky because of the decimals that we get, but let's figure it out. 0.88 repeating versus 0.88 that stops. If you, once again, place value, look at one place value at a time, we've got 8 and 8 that tie. And now look at the next one. We have a third 8, but since we don't have a third number, it's as if there's just a 0 there. So because this 8 beats this 0, this number is larger, so 8/9 is greater than 22/25. So now we just have 4 different rational numbers that we want to order least to greatest or smallest to largest. And I would say the easiest way to do this is to change all of your numbers to decimals. So 2 of them are already decimals, let's change the other 2. Let's place these numbers on our number line and then order them smallest to largest. So 0.77, if we have 0 and 1, 0.5 would be here. So we've got 0.77, and then 0.78 will just be a little bit to the right. And then 0.8, wow, these are all really close. And then negative 3.1, so way over here. So the smallest one is negative 3.13, and then the next smallest one is that would be 0.77, which is 10/13, and then 0.78, which is the 15/19, and then 0.8. Fabulous. Why don't you try this one all on your own? Pause the video, write it down, and see if you can order them smallest to largest. Well, that was pretty easy. They were already in order. Have fun with your lesson on rational numbers.